This is our last set of notes with solving quadratics, and we are finally ending it off with the quadratic formula, which should not be brand new to you. You have seen this before in Algebra 1, and there's actually that cute little song for remembering the quadratic formula, but I will spare you and not sing that. So when we have our quadratic, we use our coefficients on our terms and our constants, a, b, and c, to solve for x using our formula, negative b plus or minus the square root of b squared minus 4ac divided by 2a. So when we are going to solve a quadratic in this way, the first thing that we do is identify what a, b, and c are. So in this quadratic here, a is 1, b is 4, and c is 1. And now I'm just going to plug everything into my formula. So this will be negative 4 plus or minus the square root of 4 squared minus 4 times 1 over 2 times 1. So now we're going to simplify what's inside of our radical and evaluate from there. So 4 squared is 16. Negative 4 times 1 is just going to be minus 4. 2 times 1 is 2. This leaves us with the square root of 12 over 2. Square root of 12 can be simplified. It has a factor of 4, which is a perfect square. So this is going to be negative 4 plus or minus 2 square root of 3 over 2. And then the negative 4, the 2, and the 2 all have a common factor of 2, so I can reduce it. And it'll be negative 2 plus or minus the square root of 3. Those are my two solutions for that quadratic. Okay. Now, part of our quadratic formula is what we call the discriminant. That's b squared minus 4ac. That's the part that's inside of our radical. And our discriminant will actually give us an idea of what kind of solution we're going to have. So let's take a look at an example here. So remember, our discriminant, b squared minus 4ac. I first need to identify what a, b, and c are. This example 1 here, a is 1, b is 6, and this is not equal to 0. So I need to move that 16 over, and that's going to give me x squared plus 6x minus 16 equals 0. So my c term is negative 16. So now let's find our discriminant. 6 squared minus 4 times 1 times negative 16. It's going to be 36. That becomes positive 64. So it's 100. Okay, so that's my discriminant. Now let's plug it into our full quadratic formula to find our solutions. So x is going to be negative 6 plus or minus the square root of my discriminant, which we already found, all over 2 times a. Now the square root of 100 is 10, so that's going to be negative 6 plus or minus 10 over 2. And these are all whole numbers, so I can go ahead and solve this out. So that's going to be negative 6 plus 10 over 2, or negative 6 minus 10 over 2. Negative 6 plus 10 is 4, divided by 2 is positive 2. Negative 6 minus 10 is negative 16, divided by 2 is negative 8. So there are my two solutions. Now, our discriminant was a perfect square. And our solution was 2 real rational numbers. So anytime that you have a discriminant that is a perfect square, you can expect to have 2 real rational numbers as your solution. So let's see what other kind of solutions we get with different discriminants. Moving on to example 2, a is negative 1, b is negative 4, and c is 8. Remember, our discriminant is b squared minus 4ac. So our discriminant on this one is going to be negative 4 squared minus 4 times negative 1 times 8. So that's going to be 16 plus 32, which is 48. So my discriminant is 48. Now let's plug this into our quadratic formula. If I have the negative of a negative, it becomes positive. So it's going to be positive 4 plus or minus the square root of our discriminant over 2 times a. And this pen is running out, so I'm going to do a quick little switch here. Now, the square root of 48 can be simplified. 16 is a factor of 48, so I'm going to rewrite that as 4 square root of 3. And then to simplify 4, 4, and negative 2, I can divide each of those by negative 2. So I'll get negative 2 plus or minus 2 square root of 3. And those are my solutions. Now my discriminant here was positive, and it was a non-perfect square. So what I ended up with were two real but irrational numbers as my solution. So, sorry, brain fart. So if we have a positive non-perfect square as our discriminant, our solution is going to be two real irrational numbers. On to number 3. A is 18, B is negative 24, and C is 8. So let's find our discriminant. B squared minus 4 times A times C. Negative 24 squared is 576. Negative 4 times 18 times 8 is negative 576. So our discriminant here is actually going to be 0. So x is going to be negative b, so positive 24, plus or minus the square root of our discriminant, which is 0, over 2 times a. So the square root of 0, I'm running out of room, so I'm just going to bring it down here, is 0. So this is going to be 24 plus or minus 0 over 36. 24 plus 0 is 24, and 24 minus 0 is also 24. So both of these reduce to 2 over 3, and I end up with the same solution twice. So when my discriminant is 0, it gives me one rational, this is a rational answer, repeating solution, meaning I have the same solution twice. All right, on to number 4. A is 2, B is negative 4, and C is 5. Let's find out what our discriminant is. B squared minus 4 times A times C. That should be a 5. Sorry, it looks kind of funny. So that's going to be 16 minus 40, which is negative 24. Oops, blurry. Okay, so plugging this into our quadratic formula, x is going to be 4 plus or minus the square root of negative 24 over 2a. And uh-oh, I have a negative inside of a square root, but we know what to do with that. It's just going to be an imaginary number. So this is going to be 4 plus or minus. The square root of 24 does simplify to 2 square root of 6, and then I have that I because I had my negative inside of the radical. And now we can simplify this. 4, 4, and 2 can each be reduced by a factor of 2. So 2 plus or minus the square root of 6i over 2 is going to be our final answer. Now, we had a negative discriminant here, and that gave us 2 imaginary solutions. Okay? So, we just got one more now. So, I need this to be equal to 0, so I'm going to move that 8 over. And now I can identify A, B, and C. And now I'm ready to look for my discriminant. So 4 squared minus 4 times A times C. It's going to be 16 plus 96, which is 112. Now this discriminant is a positive, non-perfect square. So we can already have an idea of what kind of solution we're going to have here. If we go back to number 2, we also had a positive non-perfect square as our discriminant, and we got 2 real irrational solutions. So we should get 2 real irrational solutions for number 5. So let's see what we get. Negative 4 plus or minus square root of my discriminant over 2a. 112 can be simplified. It has a factor of 16, which is a perfect square. Okay, and this can simplify. Negative 4, 4, and 6 all share a common factor of 2. And so here are my solutions, and they are, in fact, 2 real but irrational numbers.